Okay, so today we are going to learn about kinematic equations. Now, kinematic equations are basically nothing but the equations in the motion chapter derived by the Newton. Okay, so these three equations are V is equal to U plus AT. The second one is S is equal to UT plus half AT square. And the third one is V square is equal to U square plus 2AS. Okay, so these three equations are very important for our numericals and also its derivation, which usually comes in exams. Okay, so what we are going to learn is the algebraic derivation of these three equations. Okay, so the first one, which is V is equal to U plus AT. It's very simple. Now it's nothing but our formula for acceleration. Okay, now acceleration is change in velocity upon time. Okay, now change in velocity is nothing but final velocity minus initial velocity upon time. So final velocity is written as V, whereas initial velocity is written as U upon time, and acceleration is written as E. Now what we are going to do is we are going to move this denominator time t over to the left hand side, which will come in the numerator, and it's going to be AT is equal to V minus U. Okay, so now the next step, it's going to be this minus U over here. We are going to move it on the left hand side, and its value will become plus U plus AT is equal to V. Now we can easily exchange these two values. So our formula will now become V is equal to U plus AT, which is nothing but our first kinematic equation. Okay, so now we are going to learn about the second kinematic equation, that is S is equal to UT plus half AT square. Now S stands for displacement in this case. Okay, so now how will we derive this equation? Now we know the formula for velocity, which is displacement over the period of time. Okay, now we'll find out, since the LHS value is displacement, we'll have displacement over here and we'll shift this time along with the velocity over here. Okay, so it's going to be velocity into time. Okay, now this velocity will nothing but, let's say there's a change in velocity, it's going to be initial plus final velocity upon 2 into time t is nothing but our displacement s. So now from the first kinematic equation, okay, so from first equation we know V is equal to U plus AT. Okay, so we are going to substitute this value of V over here as U plus AT. Now the value it's going to be U plus AT upon 2 in brackets into time t. So U plus U will now become 2u plus at upon 2 in brackets into the time t. Okay, so we're now going to divide and multiply this. Okay, we're going to divide, separate this division. Okay, so it's going to be 2u upon 2 into t plus at upon 2 into time t. Now this 2 and 2 will get cancelled. This value we are going to get is ut. Now this is going to be half a, and time into time becomes at square. So this is how we derive our second kinematic equation, which is s is equal to ut plus half at square. I hope everyone understood this. And then now we are going to learn about the third kinematic equation. The third kinematic equation is E square is equal to U square plus 2AS. Now we are going to use the same equation, that is displacement is equal to, so this displacement is equal to velocity into time. Now similarly, velocity will again be initial velocity plus final velocity upon 2, which is nothing but our average velocity into time, okay, which we are going to write down as t, and the displacement is going to be s. Now from the first kinematic equation, which is v is equal to u plus at, we are going to write down as at is equal to v minus u, and then t is equal to v minus u upon a. Okay, so now we are going to substitute this value of t as v minus u upon a. So now equation will now become u plus v upon 2 into v minus u upon a. Okay, I hope everyone understood till here. Now since the value of initial velocity and final velocity over here are same, and in positive, we can replace this as v plus u and write it down. It's going to be the same upon 2 into v minus u. Okay, and now since both are in multiplication, we can have a common division and it becomes 2 into acceleration. Now we know in the formula, okay, from the mathematical formula, that is a plus b into a minus b is equal to nothing but a square minus b square. Okay, so using this formula, the mathematical formula, which is a plus b into a minus b is equal to a square minus b square. Similarly, in this case, our a and b is nothing but final velocity and initial velocity. Okay, so v plus u into v minus u is now going to be v square minus u square upon 2a is our displacement. So now what we are going to do is we are going to shift this denominator 2a over to the numerator side on the left hand side. So it's going to be 2as is equal to v square minus u square. So now what we are going to do is we are going to shift this minus u square over to the left hand side, and now it's going to become u square plus 2as is equal to v square. Now we are going to replace this left hand side with right hand side. So now equation will become v square is equal to u square plus 2as, which is nothing but our kinematic equation. I hope everyone understood this clearly, and these were the three equations explained in the very simple format.